So let's prove that the height of an AVL tree is actually of order log n. And the trick that we're going to use here is the question that we are actually interested in is, given n, how large can h be? But we're going to ask a reverse question, given h, how small could n be? And that then answers our original question. So for that, we are going to define for a given h, what is the minimum number of nodes for that height. And the claim is that this is bounded from below by 2 to the h half minus 1. And so the base cases go through. We want to look at the induction step. So in the induction step, we're going to have a tree of height h. One of the subtrees will have height h minus 1, otherwise the tree wouldn't have height h. And the other one could have height h minus 2, h minus 1, or h. But if we want to minimize the number of nodes, so we're interested in the kind of smallest possible number of nodes, we can assume that this has height h minus 2, because that's the way we get as few nodes as possible. So what we have at the moment is that the minimum number of nodes in an AVL tree of height h is, and now we count all of this together, so we have the root that gives me one node, then I have the left subtree that has height h minus 1, so I count the minimum number of nodes in a tree of height h minus 1 plus the minimum number of nodes in a tree of height h minus 2. Now, if I make the left subtree smaller, that only kind of reduces the number of nodes. So if I kind of simply assume that I'm counting the minimum number of nodes in a tree of height h minus 2, that just gives me a lower number, and if I'm interested in a lower bound, I can simply replace that here. And the 1, obviously, I can also, if I just want to lower bound, I can make use of that. 1 is positive, so I'm left with 2 times n of h minus 2, and if I plug in the induction hypothesis, this gives me 2 times 2 to the h minus 2 divided by 2 minus 1, which then simply is exactly the bound that we wanted to get. So now I know that n of h is at least 2 to the h half minus 1. So if I now look at log n, so now I'm given n, let's say I'm given n and I'm given h. So I know that log n will be at least log n of h. So log n is at least as large as log of the minimum number of nodes of a tree of height h, because n is at least as large as n of h. And this is then at least log of this number here, 2 to the h half minus 1. So log to the 2 or to something, that's simply the something that stays, so that is 2h divided by 2 minus 1. So log n is at least h half minus 1, meaning that h is bounded in terms of a term times log n. So h is bounded, is in O of log